61 meters below the surface of the Atlantic Ocean, an underwater robot just crossed a threshold that no human being has ever crossed. And the footage it transmitted back to the surface stopped the entire research team cold. Within 48 hours of that transmission, NASA, an agency whose entire mandate is outer space, quietly rerouted 2 of its senior specialists to a vessel sitting off the coast of the Azores. Nobody announced it. Nobody issued a press release. But we know it happened. And tonight we are going to tell you exactly what that robot found. The location they've been watching for decades. This doesn't start last week. This doesn't even start last year. To understand why what happened 61 meters below the Atlantic Ocean matters so much, you have to go back, all the way back to 1972, when a Soviet oceanographic survey vessel called the Academic Kurchatov was running a routine magnetic anomaly sweep through a corridor of ocean roughly 300 miles southwest of the Azores island chain. What they found on that sweep was not routine. The magnetic readings in one particular zone were so irregular, so wildly inconsistent with the surrounding seafloor geology, that the Soviet team flagged the coordinates and transmitted them back to Moscow with an urgent classification. Those coordinates were then buried inside a Cold War intelligence archive. Not published. Not shared. Buried. We did not find out about them until 1991, when the Soviet Union collapsed, and a portion of its classified scientific archive was made available to Western researchers under a joint declassification agreement. A marine geologist named Dr. Aron Mykov was one of the first Western scientists to go through that particular file. He later described what he found as the most anomalous subsurface magnetic signature he had ever seen in 30 years of reading ocean floor data. Mykov published a paper in 1993. It got almost no attention. The mainstream oceanographic community was not particularly interested in chasing anomalies in a region that Plato had loosely described more than 2,000 years ago as the location of a drowned civilization. Scientists do not like that kind of association. It makes the work look fringe before anyone is even done with the work. But the coordinates stayed on certain people's radar. In 2004, a private research consortium, funded partially through a European Geological Foundation and partially through sources that have never been fully disclosed, sent its first submersible down to that location. What it found on the seafloor was a massive plateau of stone that did not match the surrounding volcanic base, Olu, that makes up the bulk of the mid-Atlantic ridge. The stone was different. The formation was different. And arranged across the surface of that plateau were linear structures, long, straight ridges of material running at right angles to each other that natural geology does not produce. They came back in 2008. They came back in 2012. Each time, the technology got better and they got closer. Each time, the data got stranger and the questions got louder. And then last year, they finally built something capable of going all the way in. The robot they built for this moment, the vehicle at the center of this story, is called ARIA, Autonomous Remote Investigation Apparatus, and it is not a standard oceanographic remotely operated underwater vehicle. Most remotely operated underwater vehicles are designed for relatively shallow work. Pipeline inspection, shipwreck documentation, coral reef mapping. ARIA was built from the ground up for one specific environment: confined, deep, architecturally complex underwater spaces. The team behind it spent 4 years on the design. The primary engineering lead is a woman named Dr. Celine Marsh, who previously worked on cave diving robotics for NASA's Subsea program, a program that uses underwater cave environments as analogs for exploring oceans on other worlds. We will come back to that NASA connection, because it matters a great deal. ARIA is compact. It measures roughly 1.2 meters in length and just under half a meter in diameter. It carries 6 independent thruster arrays that allow it to hold position, rotate in place, and navigate extremely tight corridors without the turbulence that larger vehicles create. Turbulence is a serious problem in enclosed underwater spaces. It kicks up sediment, destroys visibility, and can destabilize fragile structures. Aria was engineered to move through water the way a dragonfly moves through air. Precise, minimal disturbance, total control. Its sensor suite is where it becomes genuinely extraordinary. It carries a forward-facing stereoscopic camera array capable of producing photogrammetric three-dimensional maps in real time. It carries a suite of spectrometers that can analyze the mineral composition of surfaces without contact. It also carries acoustic resonance equipment, essentially sonar built for architecture rather than navigation, that can determine the interior structure of walls, whether a surface is solid or hollow, and whether there are voids or chambers behind it. That last capability is the one that matters most for what happened. The team had been using acoustic resonance data from previous dives to map the plateau remotely for the better part of 18 months. Those maps had revealed something that the external surveys could not confirm. Beneath the visible plateau surface, there appeared to be a network of enclosed spaces, rooms, corridors, and at the center of the network, a space significantly larger than anything surrounding it. They called it the central chamber on their internal maps, a name that was descriptive and provisional, the way working scientists name things before they know what they are actually dealing with. Aria was built to go inside it. On the 14th of this month, it finally did. The support vessel had been sitting at the coordinates for 11 days before the dive team declared conditions acceptable. The Atlantic at that location is not a gentle body of water. Subsurface currents in the mid-Atlantic ridge zone run unpredictably, and even at 60 meters of depth, current anomalies can throw a small vehicle off course by enough to matter. The team had been waiting for a window, a period of relative current stability long enough to complete the transit from the surface to the plateau entry point and back. On the morning of the 14th, that window opened. Aria was deployed from the stern of the vessel at approximately 6:40 in the morning, local time. The descent took just under 22 minutes. At roughly 40 meters, the cameras registered a visible change in the water column, a thermocline, a layer where cold deep water meets the warmer upper ocean, and below it, visibility improved dramatically. The seafloor at that location is unusually clear. Very little particulate matter. The research team had noted this in previous dives and speculated that some characteristic of the underlying geology might be responsible, though they had not been able to confirm a mechanism. At 61 meters, Aria's cameras picked up the plateau edge. The team watching from the surface vessel later described this moment in their dive log as immediately disorienting. Because the plateau does not look like ocean floor, it does not have the rough, irregular, organically chaotic texture of natural seafloor. The surface is flat, in a way that seafloors are not flat. It has texture. It is not smooth, but the texture is regular, repeating, and the linear structures visible from above, the right-angle ridges that earlier dives had documented, are far more pronounced up close. They are not subtle geological features that a trained eye might interpret in multiple ways. They are, by every visual account from every team member who reviewed the footage, walls. Aria navigated along the exterior of the plateau for approximately 34 minutes, following a pre-planned survey route while its sensor suite gathered data. The acoustic resonance equipment confirmed the hollow interior. The spectrometers began returning composition data on the wall material, and this is the first point in the dive where things got strange. The material was not basalt. It was not any of the volcanic rock types that dominate this region of the ocean floor. It was a dense, silica-heavy stone with a mineral composition most closely resembling a type of quarried sandstone found in North Africa and parts of the ancient Mediterranean. This was unexpected and striking in the middle of the Atlantic Ocean at 61 meters depth. The entry point, the gap in the exterior wall through which Aria had been planned to pass, was located on the eastern face of the plateau. Acoustic mapping had identified it months earlier as a roughly rectangular opening approximately 2 meters high and just under a meter wide. When Aria reached it and the cameras transmitted the first close image back to the surface, the team lead on watch had to stop the feed and call the rest of the team to the monitoring station. The edges of the opening were dressed. That is the term in archaeology and architecture. The stone at the edges had been shaped, deliberately and precisely. Not by water erosion, not by geological pressure, by tools. Aria went through what the robot found inside the chamber. The first thing that registered, before the cameras could even properly orient in the darkness, was the acoustic data. Aria's resonance equipment, which had been mapping the interior of the structure from the outside for months, had suggested a large central void. The team's working estimate had been a space perhaps 20 meters across. When Aria crossed the threshold of the entry point and the acoustic sensors recalibrated to the interior environment, the actual dimensions came back. The space was not 20 meters across. It was closer to 60 meters. The team on the surface went quiet. The dive log records no verbal communication for approximately 90 seconds after that data appeared on the screens. Then someone said quietly, "That's the size of a cathedral," and the recording picks up the sound of several people exhaling at once. Aria's lights, 4 independent arrays capable of illuminating at a combined output of 12,000 lumens, were not sufficient to light the entire space. The vehicle moved forward slowly, cameras sweeping, and what the footage showed built incrementally, the way a photograph develops. First the floor, which was flat stone, largely clear of the sediment that typically accumulates in enclosed underwater spaces over long periods of time, a fact that the team found immediately puzzling because the entry point was open enough to allow water circulation, and water circulation carries sediment. Second, the walls, which were stone, vertical, and featured a repeating series of recessed rectangular sections, not decorative, or at least not obviously decorative, but structural in appearance, as though the wall had been built in sections rather than poured or carved from a single mass. And third, as Aria moved toward the center of the space and its cameras tilted upward, the ceiling. The ceiling is what the team talks about when they talk about this dive. It is vaulted, not in a rough cave-like way, in an engineered way. The vault runs the length of the chamber, and its apex, according to the structural data Aria gathered, sits approximately 14 meters above the floor. The stone of the vault is arranged in a radial pattern, blocks set at angles to each other in a configuration that distributes load across the arch rather than concentrating it at any single point. This is called voussoir construction. It is the same engineering principle that the Romans used to build their aqueducts and their amphitheaters. It is not something that water or pressure or geological time produces on its own. At the center of the chamber floor, Aria's cameras documented a structure. It is circular, roughly 4 meters in diameter, raised approximately half a meter above the surrounding floor, and composed of a darker stone than the walls, almost black in the camera's light where the walls are pale tan. Around the perimeter of the circular structure at regular intervals, carved channels run outward like spokes from the center. There are 12 of them, counted later by the team when reviewing the footage frame by frame. Each is approximately 20 centimeters wide and of consistent depth. The spectrometers could not fully identify the dark stone of the central structure in the time Aria had available. The silica-heavy composition of the walls was confirmed throughout the interior. Additional data from the acoustic resonance equipment indicated that the floor beneath the central structure was not solid. There is another void below it. There is something underneath the chamber. Aria was in the space for 1 hour and 17 minutes before the team called it back to the surface. The battery reserves required for a safe return left no room for extension. Aria's dive log records 112 minutes of total mission time. The footage fills approximately 60 gigabytes of storage across all camera arrays. The team spent the next 18 hours reviewing it before anyone slept. Why NASA got the call? Here is where a lot of people get confused, and understandably so. NASA is a space agency. Its mandate is the exploration of space. Its budget comes from Congress on the premise that it is studying the cosmos, not the ocean floor. So why, within 48 hours of this dive, did 2 NASA scientists board a flight to the Azores? The answer requires understanding something about NASA that most people do not know. It has been doing ocean science for a very long time, and not incidentally. Since the 1990s, NASA has operated a program studying what are called ocean-world analogs, underwater environments on Earth that resemble, in meaningful ways, the conditions believed to exist on ocean moons in our solar system. Europa, one of Jupiter's moons, is believed to have a liquid water ocean beneath its icy surface. Enceladus, orbiting Saturn, almost certainly does. We have watched it actively vent water vapor into space through geysers at its south pole. Titan may have subsurface liquid environments as well. NASA's interest in these places is not abstract. The agency has been planning missions to Europa specifically for more than a decade, and a primary scientific question driving those missions is whether liquid water environments on other worlds could support life or evidence of past life. To answer that question, they need to understand what life in enclosed, lightless, deep underwater environments looks like and how it survives. Earth's ocean caves and enclosed underwater geological spaces are the best available laboratories for that research. This is what the Subsea program is. Subsea stands for Systematic Underwater Biogeochemical Science and Exploration Analog. This is the program that Dr. Celine Marsh, Aria's engineering lead, worked within before she joined the private consortium that built Aria. That connection is not coincidental. When the footage from the 14th came back and the team began to understand what they were looking at, Marsh made a phone call. She called a former colleague at NASA's Jet Propulsion Laboratory, a researcher named Dr. Kwame Asante, who specializes in the geochemistry of enclosed liquid water environments, and who has spent the last 6 years working on astrobiological preparation protocols for Europa mission planning. Asante reviewed a portion of the footage remotely within 24 hours. According to a source with direct knowledge of that conversation, he told the team that he needed to be on that boat. He and a second Jet Propulsion Laboratory researcher, whose name has not yet been confirmed, were on a flight that same day. The official explanation, to the extent that there is one, is that NASA scientists are participating as observers in a private research mission with potential astrobiological relevance. That explanation is technically accurate. It is also incomplete in ways that matter, because NASA does not send senior Jet Propulsion Laboratory researchers to private vessels in the middle of the Atlantic on 48 hours notice unless the urgency is real. The question of why the urgency is real, why this could not wait for a formal research proposal and a grant cycle and a peer review process, takes us to what the architectural data actually implies. The architecture that shouldn't exist. Let us be precise about what we know and what we do not know, because this is a story where precision matters. We know the plateau exists. It has been documented in multiple dives by multiple teams over more than 20 years. We know the stone composition of the plateau structures does not match the surrounding seafloor geology. That has been confirmed by spectrometric analysis on multiple independent occasions. We know the interior space exists. Aria's acoustic data, gathered before the dive, and confirmed during it, is not ambiguous on this point. We know the interior features, the vaulted ceiling, the dressed entry threshold, the central circular structure, the radial channels, the regularity and right-angle geometry of the walls are documented on 60 gigabytes of high-resolution footage reviewed by multiple researchers. Here is what those things mean when you put them together. The last time the area currently occupied by the Mid-Atlantic Ridge Corridor southwest of the Azores was above sea level was during the last glacial maximum. At that time, global sea levels were approximately 120 meters lower than they are today. That period ended roughly 11,600 years ago, when the glaciers melted and the sea rose. Any structure now sitting at 61 meters of depth in this region of the Atlantic would have been built before that sea level rise, or it would have to have been built underwater, which the architectural evidence does not support. Vaulted ceilings and dressed stone thresholds are not things you build in water. You build them on land, and then the water comes. 11,600 years ago. The construction techniques visible in the ARIA footage, voussoir vaulting, regular ashlar-style wall construction in large dressed blocks, and sophisticated spatial planning at a scale of 60 meters across, are not consistent with what mainstream archaeology tells us human beings were capable of 11,600 years ago. At that point in the standard archaeological timeline, human beings were hunter-gatherers. They had not yet developed agriculture. They were not building cities. They were not engineering vaulted stone chambers 60 meters across. That is the mainstream position, and that is why this footage is not just oceanographically interesting. It is civilization, historically explosive. Because if this structure is what the evidence suggests it is, it means that at some point before the end of the last ice age, someone built a monumental stone complex on land that is now 61 meters underwater in the Atlantic Ocean. Someone with architectural knowledge, engineering capability, and construction capacity that our current model of human prehistory says did not exist. The researchers on the vessel have been careful not to use the word Atlantis publicly. They use terms like anomalous pre-submergence structure and unclassified prehistoric architectural site. They are scientists, and scientists are careful with language. But Plato described Atlantis as a civilization that existed before a great cataclysm drowned it. He described its location as being in the Atlantic. He described it as having been destroyed 9,000 years before his own time, which would put the event at roughly 11,500 years before the present day. The match is not exact. It is close enough that the people on that vessel are not sleeping very much, what they are not telling you. There are several things about this story that the team has not publicly disclosed, and which we have pieced together through a combination of source conversations, document review, and careful attention to what people do not say, which is sometimes more informative than what they do. The first is the biological data. ARIA's sensor suite includes a water sampling system that draws ambient water from the surrounding environment and runs it through an onboard analytical array. In enclosed, deep underwater spaces, water chemistry is often radically different from the open ocean, with different dissolved gas concentrations, different mineral saturation, and different microbial communities. When ARIA was inside the chamber, it ran 3 water samples. The results of those samples have not been released. The team's public communications since the dive have focused on the structural and geological findings, and they have not mentioned the water chemistry at all. Water chemistry. This is exactly what Dr. Asante, the NASA researcher who flew to the vessel within 48 hours, specifically studies. He studies water chemistry in enclosed, deep liquid environments, the biological and chemical signatures of what lives in those spaces, and what those signatures tell us about the conditions present. His presence on the vessel and the silence around the water sample data are almost certainly connected. Dr. Asante. The second thing they are not talking about is the chamber below the chamber. ARIA's acoustic data confirmed a void beneath the central circular structure on the chamber floor. The team has not commented on this finding publicly, but the acoustic map, which was partially described in an internal working document circulated among a small number of researchers, suggests this lower space may be significantly larger than the chamber above it. One reading of the resonance data puts its estimated diameter at over 100 meters. If accurate, that is not a basement, that is another building. Void. The third thing is the imagery from the final 12 minutes of Arya's time inside the chamber, before the team called it back. The published footage, shared with a small number of outside researchers, covers the first 65 minutes of the interior survey. The final 12 minutes of interior footage have not been shared outside the immediate team. When asked directly by one of the outside researchers, the team's response was that the final footage is under active review. In research context, that phrase typically means one of two things. Either the footage contains a technical anomaly the team is trying to characterize before presenting it, or it contains something they have not decided how to handle yet. 12 minutes. 12 minutes of unreleased footage from the central chamber of a potentially 11,000-year-old stone complex at the bottom of the Atlantic Ocean. NASA is on the boat. The team's next scheduled dive, which will deploy Arya for a longer mission with extended battery reserves and an additional acoustic mapping array, is in 6 days. Next, we want to be clear about something before we close out tonight. This story is unproven. The structure has not been fully excavated or documented. No independent research team has been given full access to the area footage. The water sample data has not been released. The acoustic maps of the lower chamber have not been published. This is early stage, access restricted, privately funded research that is being conducted without the kind of peer review and open data sharing that mainstream science requires before it accepts any conclusion. We are not telling you that Atlantis has been found. We are telling you that something has been found. Something that is architecturally complex, geologically anomalous, historically inexplicable under our current model of human prehistory, and significant enough that a space agency rerouted its specialists to the site within 2 days of the first footage. Those are facts. What they mean is a question that is going to take months, maybe years, to answer properly. But here is what we know about how these things go. The first dive into King Tutankhamun's tomb happened in 1922. The first photographs came back blurry and partial, and the full scope of what was inside wasn't understood for months. The discovery of the Antikythera mechanism, that extraordinary ancient Greek computational device pulled from a shipwreck in 1901, wasn't understood well enough to publish on for decades. The terracotta army in China was hit by a farmer's shovel in 1974, and it took years before anyone grasped the scale of what was there. The pattern with genuinely significant discoveries is almost always the same. Something surfaces. The immediate evidence is fragmentary. The initial response from the establishment is caution or skepticism. And then, over time, the weight of evidence builds until the conclusion becomes unavoidable. We are at the beginning of that process tonight. Arya crossed a threshold that no vehicle has ever crossed before. The footage exists. The data exists. The NASA researchers are on the vessel. 6 days from now, Arya goes back in, and this time, with extended range, it may reach the chamber below the chamber. Whatever is down there has been there for a very long time. It waded through the Ice Age, and through the Flood, and through every century of human history since. It can wait 6 more days. We'll be here when the next footage comes back. Make sure you are too.